Hello again, everyone. Welcome back to our Lee County Library Science Club. It's great to have you with us again. I just want to remind everybody that all of our experiments do have a slight amount of risk to them. So please make sure you have your parents' permission and some supervision when doing these experiments. Now, today we are going to go into full mad evil scientist mode, and we are going to create a bomb! Whoa. Hold on. Isn't that like a really terrible idea? No, I don't know what you mean. Well, isn't there maybe an easier and safer and less insane way that we could demonstrate chain reactions and potential energy? Yeah? No, I don't think so. Yeah, there definitely is. So, as fun as it might be, I really don't think we're going to be needing the mad scientist today, okay? Oh, are you sure? Yeah, I'm sure. Bye! Okay, sorry about that, everyone. Now that we're back to normal, we can get on with our experiment, yeah? So, today we are talking about chain reactions and potential energy and how they work together to create some really cool things that can happen. The biggest key to this whole concept is what's known as the first law of thermodynamics. And thermodynamics is a branch of science that studies energy. How energy moves, what energy does, how we use energy, all that kind of stuff. And the first law of thermodynamics is that energy within a closed system cannot be lost or destroyed. It just transfers or moves from one object or state to another. What do we mean when we talk about energy? Because that whole idea is just a little bit vague and cloudy and hard to understand. Well, unfortunately, no matter how we try to explain it, it's still a little bit hard to grasp. But one of the scientific definitions of energy is the ability of an object or system to do work. And what do they mean by work? Well, work, as it is defined there, is the transfer of energy from one object to another. So see how it gets a little bit odd and vague? Because that's a very circular definition. Work defines energy, and energy defines work. They kind of just go together. But the basic idea is that energy is the ability of something to move that energy with a purpose into something else. The other concept that goes along with work and energy is the idea of power. Power is the rate at which energy is transferred. Okay? So something like one of those giant spotlights that we see at the airport that shines light way up into the sky. That has way more power than a little handheld flashlight that you might have at home. Okay? They both are using energy and doing work to produce that light, but one is doing it at a much faster rate, and so it has way more power. We've talked a lot about energy being transferred. Well, what does that mean, that energy can transfer from one state to another? The two main states of energy are what is known as potential energy and kinetic energy. So potential energy really is basically what it sounds like. Energy that is stored, ready to move, ready to do something, but not moving. Okay? And this can be created by the relative position of two objects, or like the internal tension within an object or a system, or maybe an electrical charge. The most common form, or most common source of potential energy is simply gravity, the gravity of the Earth. For instance, me lifting this book up just created, or not created, but invested potential energy into this book because it is now farther from the Earth than it was, right? And when it was down here, there's some potential energy because it's up on the table. So the higher I lift it, the more work gravity can do on it by pulling it down, right? Like right now I'm holding it and it feels kind of heavy because the gravity is pulling on it and putting potential energy in it to, when I release it, fall down. So some other common sources of potential energy that you might have in your daily life would be like a battery, right? That has a charge of electricity in it that's not actually doing anything until you hook it up to an electronic device. And then it starts using that energy. But when it's just by itself, it has a lot of potential energy in it. Another common form of potential energy, and the one that is most applicable to what we are doing today, would be like a coiled spring, okay? Where it's got those coils built into it, and you wind it up or compress it, and it's ready to push and launch whatever is pushing against it away, okay? Now, when that coil releases, or when I drop the book, when that energy starts moving and starts doing something, that is what's known as kinetic energy. Kinetic energy is basically energy in motion, all right? Energy that is pushing or moving or expanding or shining or getting hot, all right? Energy doing something is kinetic energy. Today, we're going to show how you can use potential energy to create a chain reaction of kinetic energy and how that can power an action. So what is a chain reaction? Well, the scientific definition would be a self-sustaining series of reactions. But the simplest way to explain it, and the one chain reaction that we all know and have all seen, would be a line of dominoes, right? They're all standing there. You just touch the one domino at the end, and by the end of it, they've all fallen down, right? So like those dominoes, most chain reactions involve potential energy that is released through each reaction. So when you are creating a chain reaction, you are investing potential energy into objects or systems at each point along that reaction. And what happens is you trigger that reaction, or in scientific terms, the catalyst starts the first reaction. The release of potential energy in that reaction then triggers the next reaction, and so on. And so each piece triggers the next, and you create a chain reaction. In order to demonstrate that today, we are going to be using these popsicle sticks, or I guess they're also known as jumbo craft sticks. Okay? We are going to be weaving them together, and when we weave them, we're bending them a little bit, and so wood, like this, is a little bit springy, which means it has internal tension. So when we weave them together, we are investing potential energy into each popsicle stick when we put tension on it by bending it. Alright? Let's get started. So the first step is to just make an X out of your popsicle sticks. Okay? For this purpose, we want to put the one that is more to the left on the bottom. We want to put that across the top of the other one. Okay? Pick our next popsicle stick. We're going to go over the bottom of our second one and then under the bottom of the first one. Now, once you've done this, you might want to adjust them a little bit so that there's still a tail sticking out here. Okay? Next, you're going to take another popsicle stick. We're going to go over that last one we placed and go again under that first one. Okay? Now while you're doing this, you want to make sure that you keep some pressure on here and don't let it go, because if you let go, it's going to all fall apart. So once we've got this started, you just kind of keep going the same way. We go over our last one that we placed and under the tail that's sticking out. Okay? Again, we want to go over and under. Now, if you have a second person to help you with this, that's usually a good idea, because it can be a little tricky trying to hold it together and move all the pieces at the same time. Okay? Again, over that piece and under the tail of the last one. Now, once you've got it going a little bit, you can take a weight, like this book, put it on the end to hold it in place, and that way your hands are free to do a little bit more of the work. Okay? Now, as we talked about earlier, each time that I am flexing these popsicle sticks, so for instance here, I'm pulling up on this yellow one, I pulled up on that, created a flex into it. So each time it's bent and flexed, that's putting potential energy into it, because these pieces of wood want to be straight, right? They have pretty strong fibers in them that want to be straight. And so instead, we're putting a curve into them, okay? And they want to snap back to that straight. That is the potential energy that we are creating in our system. Now, once we've got our system all set up, okay, all of that potential energy stored in those popsicle sticks, what do we say we need to start the reaction? We need a catalyst or a trigger, right? Well, in this case, it's pretty cool. The simple way that we trigger our reaction is just by releasing the tension in this last piece, okay? And that will release the potential energy in this piece, which then releases it throughout the rest of the system. Okay, we ready? Here we go. Going back to the beginning, we talked about that first law of thermodynamics, right? That energy cannot be lost out of a system. It can only transfer. And why is that important for a chain reaction? Well, as we saw, we put energy into each piece and then we just held it there, right? Now, what if energy was able to be lost out of that system? We wouldn't really be able to hold it there very long, would we? Right? It would just, if we held it too long, the energy would deplete, and when we let go, nothing would happen. But because of that first law, and that energy can't be destroyed or lost, we can set up that chain reaction, and it can sit for a good long time, ready for that catalyst, so that when we need it, we can use it. So some ways that this is used in our daily life are like a nuclear reactor, okay? That's a pretty big example, but inside of those big nuclear silos, there's a chain reaction happening. It starts with, they break apart one atom, the nucleus, they break that apart, and the energy that is released by breaking that nucleus then starts breaking apart the other nucleus of atoms around them. Okay? And energy is released in each fission or breaking of each atom. And so it continues the cycle, and the extra energy that is released, we are able to harness and use for electricity. And actually, if you live right here in the Sanford area, you know that there is a nuclear power plant just up the road, and most of our electricity comes from that nuclear chain reaction. It's kind of pretty important for our daily lives, isn't it? Chain reactions and potential energy, there's some pretty important concepts to our modern world. Thank you so much for watching. As always, we enjoyed it. We hope to see you again next time. Bye.